So in basically this question, we are having angle and sphere is connected with a wire and direction of water flow is given. So what they are asking about? So basically in question, they are asking about the sphere is fully submerged and in equilibrium. Okay. So it is completely submerged in equilibrium with the wire at an angle of 68 degree to the horizontal surface. The weight of the sphere is 32 Newton. The thrust acting on the sphere is 280 Newton. The density of the water is this one. Assume that the force on the sphere due to the water flow is in a horizontal direction. Okay. So that is also given in the diagram that the water flow is in horizontal direction. By considering the components of forces in vertical direction, determine the tension in the wire. So basically tension means the force in the wire. Okay. So basically, if we
Okay.
start mounting the force, so your forces will be that one will be the weight downward direction, and second will be the upthrust. Okay, because we know that we are in water surface, so there must be a opposite force in upward direction that is known as the upthrust, and we have to find out the force that is known as the tension in a string. So this force is unknown basically. We have to
Okay,
find.
so
And
what
you said the direction of flow of water is towards right. So the opposite reaction force will be towards left hand side.
yep.
Okay. And you know that this angle
Okay.
will also be equals to 68.
Oh, because of the alternate
Yes.
angle there.
So this is the complete vector diagram related to the forces. Now we have to find out the tension.
Is there like a specific formula for it?
Okay, so basically body is in equilibrium, right? And they are asking about only vertical component. We also studied that concept in projectile. We divide components of single vector into x and y component. So they are asking about y component only. So we can say that, first of all, we can say that the sum of all forces that are vertical only on y-axis is equals to 0. Okay, because we know that body is in equilibrium. So in equilibrium, sum of all forces equals to 0, right?
Right.
And we know that a thrust is completely opposite to the weight of a body. Okay. So basically upthrust is acting in upward direction, and in upward direction there is only one force, right? And if we talk about in downward, so in downward there are basically two forces. One is in the form of tension and second one is in the form of weight. Okay. So we can say that
Okay.
if we take upthrust as the in the positive component, so other two forces will be in the opposite direction, so that will be negative, right? Like minus w and tensions y component. Okay, clear? Any confusion?
I mean, it's a bit
Basically,
confusing.
upthrust, let's suppose if we take upthrust as an action force, right? So
Okay.
these two forces will be reaction acting in the downward direction, opposite to the upthrust. Tension in string is at certain angle, so that's why we include that angle. But still, if we consider from this level, so we can say that tension weight both are in the opposite direction. as compared to the direction of upthrust. So basically upthrust is acting in upward and other two forces are in downward, but one force is acting at certain angle. So we have to include that angle also in our calculation. Okay.
Okay.
So what we need to do, you remember the formula that if we are taking y-axis, so that will be equals to sine theta, right?
Right.
So u minus w minus t sine theta, because we are taking vertical component. If we are working with horizontal component, so we will take cos theta. Okay,
Okay.
so that is the concept.
So
And
U is upthrust, W is the weight, and T sine theta is the tension force.
we know that the upthrust acting on the sphere is, this is the value of upthrust, and the weight of the sphere is 32, and we have to find out the tension. Okay, but we know about the angle, so we just substitute the values.
So when you do 280 minus 32,
Hmm.
you'll get 312, but then you move it to the other side, right?
So
So you're gonna
basically
get
312
minus equals to T sine 68, right? And then what we're gonna do is we're gonna
divide.
divide
Yes,
312 by sine 68, and you will get uh I think it's wrong my answer. Let me use my other calculator. Okay, I got 336.5 to 337.
337.
Yeah.
Okay, let me check. So 312 divided by sine 68, we are getting 347, right?
Yeah.
Mm. Okay, so basically this angle is 68. So we calculate with the reference of this angle that is taken from horizontal, right?
All right.
This horizontal, right? If we just take the direction of the opposite to the direction of the flow of water, so we calculated with respect to this angle 68, right? And if we take the angle from this point, so what will be this angle?
It's gonna be 90 minus 68.
Yes, 90 minus 68, so that will be 22. Okay,
Okay.
so from your final answer you have to subtract the value, that is 68. So what will be your final answer then?
So my final answer after I subtract 768
Hmm.
279.
Because we
Oh,
know that,
wait, answer what I got on the calculator was 337, okay? So
yes,
337 minus 68 will give me 269, but like there's decimals and stuff, so you convert it to like you round it off to 270.
because we know that this 337 is taken with the 68, that's the angle with the horizontal line. But if we take the reference from the weight, because our main purpose is with the reference of weight we need to find out the angle of the tension. right? So one thing is that we just take the angle in the start, like we just take 22 and then we solve the answer. So you will get different answer. You will get so that will be some different, but we know that initially we take the angle with the horizontal, so that is not our main purpose. We have to take the angle with respect to the weight. So that's why we take 337 and then subtract that 68 degrees. So that will give you answer 270, right? Round off. Okay.
Okay.
So this is the concept, because we know that we just solve with the given values. Then we have to identify that the angle is with the horizontal, but we don't need to take the angle with horizontal because we are considering the component of the force in the vertical direction, right? So that's why we have to take the angle with respect to the weight. Okay.
Okay.
And the next part is you need to calculate the volume. So let's see which values are given in the question that will help you to find out the volume. You remember the formula for the upthrust? Upthrust
No.
exerted by the water.
Nope.
Okay. So basically, we will also discuss that concept in the coming chapter, because that is related to the density, and we didn't talk about the density in the chapter of dynamics that is included in your next chapter. So just for the reference, I am writing the formula for the upthrust, that will be equals to density of water multiplied by volume into the value of G. Okay. So this is the
Okay.
formula for the upthrust. We will study that formula in the chapter of density. That is the next chapter after dynamics. So we will also discuss that formula. So, but for the time being, for the solution of this question, you may take the reference from this, because question is for 1 mark. So that is not much very difficult. So you will get the value of volume. So we know that upthrust is 280, density is 1000, volume
This
is.
wasn't in the O level, the upthrust, I think.
Yes, because there is only concept, and sometime we just used to write the formula just for the reference, but that is not compulsory included in our exam. So that's why when we start the chapter of density, pressure in A levels, so then you will find this formula. Okay.
Okay.
And just a minute. In the formula sheet, it is also written over here, right? So no need to worry about that. You will get this formula in the data sheet also. Okay.
Okay.
So now we can easily find out the value. Okay. 9.81, the value of G. Multiply 1000 by 9.81, divide by 280 on the other side. So you will get answer
Okay.
0.029, right?
Yep.
And secondly, we have to find out the density. Again, density is equals to mass upon volume. So volume is already calculated. And what about the mass?
Okay, so what we can do is for the mass, we know the weight is 32, right?
Weight is 32.
So we can do is 32 divided by 9.81, and then we divide it by 0.029.
Yes.
And the answer will be 110.
110.
Yeah.
And your density will be So your final
The
answer
den-
is 110.
yeah, the final
Okay,
answer
okay,
is
okay.
110. 32 divided by 9. I just put it in the calculator. I didn't calculate what the 32
Okay,
divided
okay.
by 9.1 was.
Right, so you got the answer. Density is equals to 110 kilogram per meter cube. And the next thing is the center of the sphere is initially at height of 6.2 above the horizontal surface. So they are talking about the center of the mass. So center of the mass is at height of 6.2 above the horizontal surface. And the speed of the water then increases, causing the sphere to move to a different position. This movement of the sphere causes its gravitational potential energy decrease by 77 joules. Calculate the final height of the center of the sphere above the horizontal surface. So initially, we are having, we can say,
So we know that
so let's suppose initially we are at a height of 6.2, and then they are asking speed of the water increase, and water is flowing towards right hand side. So if speed will increase, you know that this sphere will move a little bit
okay,
downward.
so we know that the gravitational potential energy is mgh.
Yes.
Energy GPE equals mgh.
Yes, you know the formula that potential energy or gravitational potential energy is mgh. So we can say that.
Right? So then we know that to find the height, what we can do is energy divided by mg,
Hmm.
which will be energy is 77. So 77 divided by the mass, which is we already calculated it. It was where is it?
So basically, you need to divide this
32
value
divided
32
by.
divided by 9.81. So basically,
But we don't. We need
yes.
mass. Oh, okay. So we need to do 32 divided by.
So it will automatically get cancel out because we know that for the mass. So basically, they will cancel out each other. Okay.
Oh, because it's the g gravitational
Yes.
acceleration.
So finally, you just need to divide 77 by 32.
And you will get 2.4.
So now we are taking height 2.4 meters. And now they are asking
So we're gonna
calculate the
do
final height
six.
of the, yes,
So 6.2 minus 2.4.
yes, because you know that we have to take the reference like this, that this is the initial and this is the final.
And the answer is 3.8.
Yes. So we are actually finding this height. Okay. So this height is
Okay.
2.4 because we calculated from the formula according to the given values. So this answer is 2.4. But in question, they are asking above the horizontal. So for this height, we have to subtract 6.2 by 2.4 and you will get the answer 3.8. So from the ground level or from the horizontal surface, new height will be equals to 3.8 meter. Okay. Any confusion?
Yes. No.
Okay. And the next part is the extension of the wire increases when the sphere change position as described in C. The wire obeys Hooke's law. So basically you have some concept of Hooke's law, right? F equals to minus kx. So in the answer they are asking, state a symbol equation that gives the relationship between the tension in the wire and its extension. Identify any other symbol that you use. So basically they are asking about the equation. So which equation we have to write in this answer?
The equation.
You remember the formula for Hooke's law, F equals to
Yeah,
minus kx.
no,
Yes,
it's F equals to kx, right?
yes. So that will
Where
be
the k
T is
is the
equals to,
constant.
yes. So we write T is equals to kx because they are asking with the reference of T, and we explain that k is equals to,
So T is equal to F.
yes, because in question they are asking about tension, and we know that tension is also a force. So that's why T is equals to kx, right?
Okay.
And the final part is before the sphere change position, the initial elastic potential energy. So the initial elastic potential energy is 0.65. The change in position of the sphere causes the extension of the wire to double. So extension is
Okay.
actually double. And the final elastic potential energy we have to calculate after the sphere has changed position.
So we can use the half mv square in this.
Okay.
Energy equals half mv square. So um we know E is 0.65 initially, right?
Basically, we use half mv square when we are working with the mass, but this time we are working with the spring and they are asking with the reference of the spring. So we may write the formula like half kx square, right? The energy for the
Okay.
spring.
Yeah. So
Basically, they are asking that the change in position of the sphere causes extension of the wire to be doubled. So according to this equation, we can say that energy is directly proportional to x square, right? So basically, if
right.
x will double,
So will E. E will also double.
so e will also increase, but it will increase 4 times because there is also a square on the extension.
Oh. So what we do is 0.65 multiplied by 4.
So we already have initial value, and for the final, this is initial. We just multiply by 4. So you will get your final energy, right?
Right.
2.6 joules, right?
Okay.
Clear? Any confusion?